If you watch a heavy, everyday commuter car suddenly launch forward like a rocket, you are usually seeing one specific invention at work. To understand how, we look at the three ingredients standard engines use to create power: air, fuel, and spark. Think of this reaction like a campfire. If you want a bigger fire, add wood and fan the flames. More air burns more fuel. Therefore, if an engineer wants an engine to generate a massive amount of power, their main obstacle is figuring out how to get a lot more air inside the cylinders. A standard car engine is what mechanics call naturally aspirated. That means it relies entirely on normal atmospheric pressure to pull in its air, just like you breathing in and out. This creates a physical bottleneck. It is remarkably similar to an athlete trying to sprint a marathon while breathing through a narrow drinking straw. The legs might have the energy, but they simply cannot pull in enough oxygen to sustain a fast pace. Because of that physical limit, pumping extra gasoline into a standard engine is completely useless. Without a way to force more air inside, that extra fuel simply will not burn. This is the exact breathing problem the turbocharger was designed to solve. It works in two parts. First, the engine naturally creates hot, rapidly expanding exhaust gas. As that hot gas blows out of the engine, the turbocharger captures it and uses it to spin a metal wheel, working exactly like a windmill catching a heavy breeze. That windmill is connected by a solid metal shaft to a second wheel, which acts as a fan. When the exhaust spins the windmill, the fan on the other side is forced to spin right along with it. As this fan spins at incredible speeds, it violently sucks in fresh outside air and crams it tightly into the engine cylinders. Mechanics refer to this highly pressurized forced air as boost pressure. Because the engine now has a massive surplus of oxygen packed inside, it can burn significantly more fuel, creating a huge surge of power. Instead of letting that hot exhaust blow straight out the tailpipe, the turbocharger effectively operates as a recycling plant, capturing waste wind and turning it into raw horsepower. But this process does create a specific challenge you might have felt while driving. When you press the gas pedal down, there is often a brief pause before the car actually accelerates. Mechanics call this turbo lag. This line chart maps out engine speed compared to the turbo speed. You can see the delay right here. The fan cannot start pushing fresh air in until the engine has created enough exhaust gas to get the windmill spinning in the first place. The second physical hurdle is heat. When you squeeze air tightly together, it gets very hot. Hot air spreads out, becoming fluffy and less dense, which means less actual oxygen fits into the engine block. To cool that air back down, engineers use an intercooler. You can think of it like the metal radiator grid on the back of a refrigerator. It chills the compressed air, packing it down dense and tight before it enters the engine. Generating reliable power requires constantly balancing that delicate equation of exhaust pressure, moving air, and extreme heat. For decades, the ability to generate massive horsepower made turbochargers a defining feature of legendary sports cars. At the very top end of performance, professional racing teams use multiple systems, like twin turbos, dividing the massive exhaust flow to maintain incredible speeds. Today, automakers use that exact same science for a completely different reason: fuel efficiency. Because of the turbocharger, car companies can install much smaller, lighter engines in everyday vehicles. While cruising comfortably on the highway, these smaller engines sip very little fuel. But the moment you need to pass a truck or merge into fast traffic, the turbo kicks in, instantly giving a small commuter car the muscle of a much larger engine. By harnessing the wind of a vehicle's own exhaust, engineers solved the breathing problem, finding a way to deliver economy and speed in one single package.